Hey everyone, welcome to the Cannabis Technology, and with me today I've got an interesting conversation with Dan Droller, VP of Soleil Technologies at urban-gro. I also have Steve Wilczek, Lead System Designer at urban-gro. How are you guys doing today?
We're doing great, Rob. Thanks for having us on your show.
Thanks as well.
Great. Well, thanks both of you, Steve and Dan, for making it. I've got a number of topics I want to hit on, but I'll kind of do a background to lay the land for our viewers. urban-gro is launching, referred to as Soleil Technologies, which is a high-density sense and control solution. So we want to chat a bit about that. It's been in development for a while, and I know urban-gro touches on a number of different products facilitating cannabis grow, but this new one, for Soleil, could be a groundbreaker or a game changer, I should say, depending on how it comes together. So I want to touch on that high level and get into some of the detail, and also talk about trends and customer demand. So, was it a customer demand that kind of drove this technology's development? Why don't we start there and talk about, conceptually, what does this Soleil solution do?
Sure. So, our urban-gro, obviously for a while, has been involved in helping cultivators get the right equipment, make the most out of grow, really designing from the walls in how people can best use their space to achieve their desired results. And so through that process, through our in-house scientists and cultivators, we're always looking for what we can do to really help people achieve the results that they want. So while this wasn't necessarily a specific request from a customer, while we're on the lookout for technology to help them identify what's going on in their grow and make the most out of it, that's what this was born out of. And we basically partnered a little bit ago with a company called Visa that had a solution for high-density Internet of Things wireless sensors. And obviously sensors is not a new technology in agriculture nor in cannabis, but what excited us about this technology is that it gives basically a higher resolution of what's going on within your grow, because it's able to overcome a lot of the shortcomings of other existing technology in terms of its ability to scale and operate at density. So what we view and what our customers have viewed it as, and our pilot customers have viewed it as, because it's obviously live in certain areas. They viewed it as a way to basically monitor all aspects of the grow, down to the bench level, down to the plant level. So instead of getting one or two data points from within the grow, you get multiple data points and really can key in the parameters that you want and ensure that your systems are operating the way that you want to throughout the crop cycle. Gotcha.
So it's broken down in a kind of a trifecta. It's really, a high-density wireless sensor network. There's the hardware itself, and then there's the data collection aspect. So you want to kind of dive into how all three of those integrate to create this solution?
Yeah. So right now we have our high-density environmental sensors, right, and those are bidirectional, low energy, operating in a tree network to really capture microclimate at scale. They are active, and their hypothetical standard. It's probably overkill, right? But it's 2,000 nodes in a 400 square foot area, and if you think about that, that's a ton. That's way more than you'd ever need, but it's pretty great that we can achieve that. And each one of those nodes, we pull them at every 30 seconds. We capture more than 8,000 data points every day. That's our standard. So we put that hardware, which is the sensor, both within and outside of the canopy, at the standard deployment that we've come up with that makes the most sense. And we set them up. They begin operating, and they pass data into our network and through what we're calling our Soleil 360 platform, which basically lets you view that data, get your room variables, your facility variables, your multiple facility variables, all set up in dashboards and data collection that you want, from any device with an internet connection, right? You don't need to be on site. And on that platform, you can basically set alerts to know when those parameters are out of whack. So to give you an example, you get the sensor set up and running. You understand where you want your climate to be for whatever you are growing, and you can check to make sure that your light dimming profile isn't really creating spots where there could be powdery mildew infestation to break out. Or if you have bench fans on, you can really quickly see when a bench fan goes out as temperature will start to go. So it really offers a much closer look and a better way to respond and work towards the ideal conditions you want in your grow. The third part that we're announcing today is obviously solar climate control. It's powered by TGC. It's a control system that's just it's modern technology. Offers easier API integration. One of the reasons we were most excited about it was because it's software-based, so it can capture a ton more data points, similar to what we're throwing off with our sensors, and it also provides a graphical interface on site that lets you simply and repeatedly input recipe formulation and propagation. So all those things together present what we feel is a pretty powerful opportunity for some of our large-scale cultivators.
Okay. And I got a good sense of that when I've watched the videos and I've been through the product literature. It almost sounds too good to be true. A couple of questions. One, regarding, for example, subclimates or segmentation within a grow. For example, you find out through there's a particular area of your grow that's it's either too moist or it's dealing with pesticides or it has an issue, and your data is telling you that. How is it that the system then optimizes to address that specific issue within that portion of the grow? In other words, what you would do, the remedy you'd have for that wouldn't necessarily apply to the whole grow operation. How is it able to accommodate that?
Sure, and maybe that's why I say it sounds too good to be true, because that's not true. Which is fine. So what it does is it alerts you to the specific area where that's happening, and that's new. What's not connected yet is that machine learning, or I guess algorithmic learning, if you want to call it that identifies that and then is able to specifically treat that area, right? So what we see that as the future, right? And we actually have shown a proof of concept at the end of last year where we actually had our wireless sensor technology hooked up to solenoids that automatically opened and closed, and we're able to do that wirelessly, et cetera. And you can obviously see in the not too distant future where we are able to detect using our substrate sensor that moisture or potentially pH is incorrect in one area, and we can selectively control a solenoid to address that, right? And that is obviously the goal. Okay. But I think we'd be remiss if we waited until we were able to do that entire package before releasing these pieces. And part of the reason for that is because each of these pieces individually, what we believe and what we've seen so far with our partners is that they offer a pretty immense value to them that hasn't existed before.
Okay. Makes sense. One of the things you had mentioned, Dan, and I think Brad, the CEO of the company, mentioned it, that one of the challenges you guys, what growing facilities have with IoT is mitigating scale, or it's basically scalability and efficiency. And I was wondering if you could talk about that, because it sounds like that the system you guys have is quite scalable. And I'm trying to get an understanding of efficiency and scalability and how Soleil addresses those issues.
Sure. So that's related to our partners, Adiza, that created this Soleil wireless technology that who we partnered with to bring it to market, right? And so if you think of IoT, and Steve, I'll sort of take lead on this, but if you want to get into more sort of specific technological details, obviously you can feel free to jump in. But basically, existing technology, right? You have wired and you have wireless. Wired is great. It doesn't necessarily scale a ton, or there's just going to be wires hanging everywhere. Wireless is great because you don't have the wires, and you can sort of scale easily. The problem with existing wireless technology is, especially IoT technology, is that there's some limitations when it begins to come to that scale. So if you think about some of the competing technologies, there's LoRa, there's Zigbee, there's Bluetooth. Each of one of those has an issue, right? So LoRa is based on a high-power star network. Zigbee, Bluetooth are low-power mesh networks. We operate in a tree network, and part of the advantage of doing that, and we're low power, part of the advantage of doing that is we actually don't have the same failure rate or packet loss that other technologies do. If you think about interference, anytime you try and use, for instance, Wi-Fi in an airplane and too many people are connected, you don't get on. Or similar, if you open up and try and connect your Bluetooth device and there are 10 other Bluetooth connectors going on, it's going to be difficult. So, LoRa, we see once you hit 60 devices, you can start getting a failure rate of greater than 25%. Once you hit 50 Zigbee devices, they'll start having failure rates, and they'll retry sending messages and packets, but that really drains the battery. Bluetooth, once you get over 160, greater than 99% failure rate. The packs just hit with each other. Our technology basically is able to overcome those limitations, and frankly, the way that they work and the way that they rely on each other, the more that you put in, the greater they actually work, which is pretty cool. Obviously, there's some proprietary aspect to it. Our partners spent 2 years specifically developing this. They're PhDs that work on some pretty intense stuff, and we're pretty both amazed and really happy with the way that the technology has worked out.
Yeah, that's really interesting. So the more you scale up, the more stable it is, in a sense?
In a sense, yeah, pretty much. And like in all industrial applications, we're trying to build in redundancy. We're building data backups. We're building ways so that when the power goes out, which often happens, that the data is not lost, and there's ways, it basically gets it back up. That the sensors, they don't need to be reprogrammed when the power goes out. They're battery powered, etc. So, we are always still learning and always looking to improve, but we're pretty happy with the way that the system is functioning right now, and so are our partners.
Okay. So tell me what can happen within 30 seconds. You mentioned that the data rate, the data is being pinged every 30 seconds, given that plants, take a while to grow. What is, that strikes me as incredibly responsive. Why is the data coming in that quickly?
Sure.
Do you follow my question?
You can, yeah, I do. So you can change that polling, right? And we call that polling. It's basically every time you get the data from the sensors is polling. And every time you get the data, you're hitting it, you're getting, at least with our environmental sensors, you're getting temperature, or you're getting humidity, you're getting barometric pressure, and a couple of other things that are basically based on the health of the sensor and the battery itself. And so the reason for the 30-second polling is just because it gives you a real-time feed of the conditions at a micro level within your grow, right? And that is valuable. So you can change that to a minute. You can change that to 2 minutes, and yes, maybe that's enough. We frankly leave it up to the cultivator to decide and tell us. But it helps you see really clearly when problems are beginning to happen and what the trends are with those problems, right? So, we view a lot of the other things available in the market as 1 or 2 signals from an entire room, maybe a couple times a day. Yes, an overabundance of data can be overwhelming, and is just that, an overabundance of data. But we think that with the trends that we provide and the multiple views within the facility at the micro level, that begins to deliver insights that you can use to as I said before, look out proactively for areas of potential pest infestation or areas of some of your equipment failing and things like that.
Gotcha. That makes a lot of sense. You know, something that really struck me, Dan, because we've interviewed quite a few solution grow facilities with sensors and technology and clouds, but what struck me the most, one of the things that really leaped out to me was the collection of soil data, what you guys label as the substrate part of the solution. Can you talk a little bit about the metric and for that metric and what it plays in cultivating growth? More specifically, how critical is it when you're growing cannabis to monitor every aspect of the soil?
Yeah, for sure. And you know, I'm not a cultivator, so we listen to our partners and our in-house cultivation experts about the need for the substrate sensor. And again, while we're live with the environmental sensors and frankly also live with some other elements that are coming soon using our similar technology that are controlling lights, we are officially saying that our substrate sensors are coming soon. But what we've sort of been told by our cultivation partners is that really, you know, once you have the environmental sensors both within and without the canopy, to really get a clear picture of the health of the plant and, you know, for instance, proactively looking out for things with pest infestation, that you really need that soil substrate sensor. And so the way we're developing it is with input from cultivators, right? It's for both loose soil and cocoa, et cetera. But we just look forward to continuing to provide additional variables and parameters and data points so cultivators can really not only dial in their grow, but ensure that they're dialing in their grow at a consistent level in the way they want to optimize their yield. Does that actually answer your question? I want to make sure you answered, and maybe Steve. Okay, good. And Steve can probably speak to more specifically about what the cultivators want. But we do know and have heard that from our in-house experts as well as our partners that it's very desired, which is why we're bringing it to market.
Yeah, I think Dan nailed it there. Basically, it's a demand-driven sensor design. We're not trying to present something that the cultivators don't need. We're merely, we did a market analysis of the most common soil sensors out there, and we work with quite a lot of very large grows that are our customers and give us vital information to drive the development of the technology in a useful way. So, rather than reinventing the wheel, we kind of stripped out everything that the cultivator doesn't need, and we spruced up what we can provide to them by way of sensor fusion technologies to complement. Our sensors are a little bit lower resolution compared to something a research-grade sensor would provide. But what we can do with machine learning is essentially take out some of the gaps in the resolution by way of sensor fusion techniques. So it allows us to provide a lower-cost sensor that provides the same data quality that the cultivator is looking to use for growing.
Yeah, I'd love to see that in real time when you guys get up and running. And speaking of, in terms of up and running, what would be the ideal size of a grower that would be ideal for the Soleil system?
There really is no true ideal size. Obviously, urban-gro and therefore Soleil, we generally work with commercial cultivators, right? And so I'd say a commercial cultivator is the ideal size. And many of our partners are testing us out in 1 or 2 rooms and then expanding from there. And those 1 or 2 rooms can then be anywhere from 10,000 square feet of canopy and up. And so that's sort of where we're targeting, but that's also generally because we work with commercial cultivators. And I think one of the advantages that they see and the reason that they're signing back up after testing is basically that it really is easy to scale and add additional things. So there's no additional system to get if you want to wirelessly control your lights once you have our environmental sensors, or vice versa, or our substrate sensors. And so it's a pretty interesting way that as we continue to work with our partners and develop the sensors that they want to see, or a better way to put it is the data that they want to see out of their grow, that we can work to develop those, and it can be easily integrated into their existing systems. And that obviously still goes along with our Soleil climate control.
Okay. So having said that, what are kind of the expectations for the system over the next several years? I know you guys are launching, which is kind of a big deal, and you're going to learn a lot. Can you tell us, or maybe talk to us a bit about what V2 might look like, and what the future holds for this? Sure. What are the expectations?
Sure. So obviously, we're releasing something when we think it's good and our partners have validated it. But we're always going to continue to look to improve, not only by releasing additional products related to the Soleil climate control tech, but improving upon what we already have. So we talked about this, I think before we officially started. But there are many different ways where we can see eventually leading to a way where you can sort of sense and then control all aspects of your grow. We're really excited by the ability of developing either insights in partnership with our partners or on our own, or frankly our partners doing it on their own because it's their data, but insights so that they can set the parameters that they want. So not only as you can currently get alerts when something goes awry, but that it ties into the actual specific control aspect of it. So that instead of, you can already do something about it, but it requires you to maybe pick up a phone or actually go into your grow and do something. In the future, obviously, we would love to see when, say 1 to 2 years from now, when that the system responds automatically based on whatever parameters you input to start doing it. We obviously love the idea that in the future that this technology can be used, for all aspects, not only the grow, but there are areas where we can talk about asset tracking as well with it. And so, as we already can control lights as well, tied into the grow, the sensors input what happens with the fertigation, what happens with the irrigation, or what happens with the lights, right? So that that's also tied in. You can access third-party data through API. So if you're in a greenhouse and you can follow the light of the sun, the cloud overcomes, you can compensate for that. So it's just really exciting what we think we can do with our technology, and we're looking forward to continuing to develop with our partners some of the solutions that they want to see.
Sure, and we'll be watching. Excellent, Dan. And I guess with that, we're gonna wind this up. But this feels like some potentially groundbreaking technology as it relates to growing inside. So I want to thank the both of you, and also ask how do we direct our listeners who want to learn more about not just urban-gro, but more specifically the Soleil solution you guys are trying to expose or promote.
Sure. So, obviously we'll be presenting this at some upcoming conferences as we have done and will continue to do. The website will be linked to from urban-gro, but obviously this is a little bit different, and this is our innovative technology side. We are at soleiltech.ag, and that's SOLEILTECH.ag. And we really look forward to hearing from people. Let us know what else you want to see. We obviously are in close contact with our partners, but we're really excited about what this is doing to the industry, and we would love to hear what you want to see from us.
Sure, and to concur with that, go to that website and see the videos and the visuals. It'll help give you a kind of a bird's eye view of some of what we talked about. It really helps to see it visually to get the full sense of the solution. So, Dan, Steve, thank you so much.
Thank you very much for the opportunity. It's really great to speak with you.
Thanks so much, guys.
For sure. Take care.
That's it, everyone. See you next time.